Indeed. So our final presenter is Goutam Nistala, who will be presenting on research on the AWS cloud. And so, Goutam, if you're ready, why don't you go ahead and get started for us?
Thank you, Rob. Can you hear me okay before I share my video?
Yeah, I can hear you great.
Perfect. And give me a second while I ensure that I'm sharing the right screen. It's always tricky for me. Okay, and I'm going to share screen now. Can you see my full screen okay, Rob?
Yep.
Perfect. And last thing I'm going to do is make sure I can actually go forward in my slides. Okay, sounds good. So I'm all set to go.
Fantastic.
Perfect. And Rob, one quick comment is I can't see the Zoom window. I have only 2 screens here. So if someone has a question, please be on the audio because I'm not monitoring the video.
Yeah, and we actually watch the chat really carefully and collect the questions for the Q&A at the end. So I want to encourage everybody to make use of that, and we should be good.
Okay, good. Would you like me to come on screen? I don't know if I'm sharing my video, but I'm trying to figure this out. Give me 1 second while I do that.
Okay, it's at your option.
Okay. I'm sharing, but then my video is.
It's fine without, oh, there you go. Great.
Oh, there you go.
All set.
Thank you. All right. So hi, everybody. Super glad to be here. So I am Goutam Nistala. I am a senior business development manager in the AWS higher education research team. And along with me here are my colleagues, Jeff Lawson, account executive for AWS, and Joel Morgan, solutions architect. So they would be helping me with any questions that you might have. And a quick brief background on myself. First of all, thanks a lot to the RRoCCET team for organizing this great event. Very insightful talks, and I'm walking away with a whole lot more enthusiasm than when they started out learning about all these innovative things that's happening in research. And so prior to AWS, I was actually a scientist leading the development of DNA sequencing oncology diagnostics products at Thermo Fisher Scientific. I worked both on the platform side, the ion torrent platform side, as well as on the chemistry side. So that goes back to my actual background as a bioengineer. I got my PhD from the University of Illinois, and then in synthetic biology approaches in bacteria, and then did my postdoc at Stanford, where I tried to use synthetic biology approaches in understanding the p53 pathway. So that's a little bit about myself, and I am here to talk to you about empowering research using the Amazon Web Services. So my goal today is to introduce you to AWS through the lens of a researcher, and people like people who help researchers or empower researchers, like research IT or central IT. So the agenda will go through the core benefits of using AWS for research, and how you could simplify access to the cloud, and how you should start thinking about your journey to the cloud, since you're here at this Cloud Bank forum. So I guess the first step is already done. And then I'll continue on with a few of the popular topics, like what the core infrastructure that powers AWS, compute and data storage, and some research solutions, and AI and ML approaches to research. So having said that, let me get into it. We love science, right? Science and innovation is at the heart of everything that we do. and that Amazon does, whether it is, let's say, Amazon Retail working on enabling one-day delivery, or enabling you to get your purchases in a few hours since you made the purchase, or Amazon Web Services providing you access to quantum computing resources to enable your research. So we love science, and throughout my presentation, I've included URLs in my deck that you could go to for more information. So and then research, it's not, I don't think of it as a domain, not as part of what we do, but spreads across everything that we do. And here are very few examples of how we were, of some of our customers. You could recognize R1 and R2 universities in here. You could see some corporations that have like really strong research programs. So research happens across industries and geographies, and some of these, and most of the examples, all the examples you see here, the research is done on AWS, and this is a very small representative sample. So typically I get to resources at the end of my talk, but more lately I've seen that when I speak to researchers or folks who enable research, this is the most favorite topic, and I always get questions about what are some of the resources we have available for you. And so I decided to bring it up front. We are big proponents of research, and here are 4 different grants that you could apply for, right? And the caveat is they are obviously selective, and then there is a selection process on who gets these grants awarded. But let me tell you briefly about them. So the first thing I would like to talk about is the Fairness in AI grant. Amazon and the National Science Foundation, we are working together to commit up to $10 million each in research grants over the next 3 years, focused exclusively on fairness in AI. And then my most favorite awards here, the Cloud Credits for Research. This program actually awards credits for AWS services to researchers thinking about hosting, like science as a service kind of applications, or something cool that you build, and then you would like to test it out, right? Perform proof of concept experiments, or you want to do some benchmarking, or something as simple as you would like to run a workshop for your grad students or postdocs, and you would like to do that on AWS. So we have the Cloud Credits for Research. Please do talk to your account team about applying for them, or I have the link there, and you can learn all about it over there. And I'll talk about the Amazon Research Awards and the Open Dataset program in the next slides. So this is the Amazon Research Awards. This is again like one of those really highly coveted awards. We have a lot of researchers applying to that. And in fact, to date, ARA have funded more than 400 research awards at 150 different universities in 28 countries all over the world, right? So these are unrestricted gifts to PIs or academic institutions or to the organization itself. Amazon does not retain any rights over your IP, your intellectual property of the resulting work. We do encourage you to publish your outcomes or commit your code to repositories like GitHub that are open source and publicly available. Recipients are assigned an Amazon research contact who offers you consultation and advice, along with, we do provide you opportunities to participate in Amazon events where you can talk to other researchers or other parts of the community. And the topics for these research awards, they are across the board, and you can think about, cloud systems, computer vision, natural language processing, robotics. So this should be of interest to you. Please do read about what these research awards are, and I have included the URL over there. And then finally, so the registry of open data, right? So we have a lot of researchers talk to us about how some of the federal grants now, like the funding organizations, are mandating that the research that they conduct is publicly available. The data is made publicly available, and we have researchers coming to talk to us about what are some ways of doing that. And this is a good program. So the registry of open data, the open data program, it enables researchers who are thinking about providing their data or making their data sets accessible to the research community. We covered the cost of transferring the data and hosting the data for a period of 2 years. And then for those researchers that just want to use the data in their research, we have an amazing set of data sets in there. And whether it is the 1,000 Genomes Project, the Cancer Genome Atlas, or some of the satellite imagery or the OpenStreetMaps, these are just some of the data sets that I personally know and that I would have liked to use when I was a researcher. So I just included those examples over there, and these are updated regularly. Actually, a lot of researchers use these publicly available data sets in their own research, and we love when researchers do that. So please do go to the registry of open data, provided the URL over there, and learn more about it, and talk to your account team if you are interested in either hosting one of these data sets or your data sets, or just using it. We have many resources for you. This is a loaded page here, but let me walk through it. So if you look at the top over there, there's a little button that says letter of support. So if you're applying for your grants and you need a letter of support from us, just go ahead and let us know through that button over there. And if you come down, you see that there are some videos, and there are examples of researchers talking about how AWS supports researchers to scale and collaborate. They're very important research. We have blog posts, and what you don't see here is we also have a portal where we have these 10-minute video tutorials. That is something my immediate team actually worked on, and it's publicly available now, where researchers could go in and get a short introduction of some favorite topics like using R on AWS, using MATLAB on AWS, things that I would have loved to learn as a postdoc and as a grad student. We also have the research, IT, and seminar series. And the research seminar series is where the researchers like you, they come to us and share their cool research, and additionally also let us know how they are using Amazon Web Services to enable and accelerate their research. And the research IT series, on the other side, are our own internal experts. We have a lot of experts in areas like genomics, geospatial data, various different areas, artificial intelligence, and our own experts talking about different research projects or how they help a specific research university. So these are all publicly available. Please go ahead and check them out. And finally, we also work with the funding organizations like NIH, NSF, European Space Agency, and NASA. I'm not going to talk about Cloud Bank because you're all here, but quickly I'll give a shout out to the NIH Strides program, right? Any customer that has a biomedical research project that is actively funded by NIH is eligible for the NIH Strides program. And that means they get a favorable pricing on AWS services up to like 9% of discount on compute, storage, and other related cloud services. So there's a lot of information. Please go ahead and check this out. Finally, we understand there is no so data is very important to you, and you are looking to use your data for collaboration, and you generate a lot of data for your research. You're always thinking about about your data. So if you want to move your data to your cloud, there is no cost of uploading data to the cloud. And we make it easier for you to use the cloud storage, computing, or other database services. However, as you know, there is a fees associated with the data transfer out of AWS to the internet. And that's what we call the egress fee. But we do provide a discount, particularly for researchers, up to 15% of your total monthly spend on your AWS services. So for most researchers, we know this egress discount, the 15% of your total AWS spend, is more than enough to cover the cost of even like downloading your data off of web services. So again, we do offer this egress discount, and please do talk to your account manager about learning more about how the data egress discount waiver works. So at the center of everything we do, it is powered by our Amazon Web Services core infrastructure. And let's talk a little bit about that. So we have about 15 plus years of experience helping millions of customers, right? And that shows. In fact, AWS services AWS is a leader according to Gartner Magic Quadrant for cloud infrastructure as a service for, I believe, the 10th consecutive year as of 2020. In addition to that, we have about the largest global infrastructure footprint. We have 81 availability zones with one or more data centers in 25 geographic regions around the world. And this footprint, it's continuously increasing, right, at a significant rate. One difference is, unlike some of the other cloud providers, our each AWS region has multiple availability zones, and within each availability zone, we have physically separated data centers, separated by earthquake fault zones, separated by electricity grid zones, things like that. So physically separated. When we have many security and compliance features that enable you to manage the security of your cloud. We have 175 plus offerings with many more when we account for our partner services as well. And one of my favorite statistics is the total cost of ownerships, where we, our innovation, we provide the cost of savings back to you. So total cost of ownership are price reductions when you use our services. And we have done around more than 85 total cost of ownership since we just started out. And majority of the machine learning that is being done on the cloud, or majority of the machine learning is actually being done on the AWS cloud. So these are some of the really strong reasons why researchers prefer to work on AWS or bring some of their workloads to AWS. If you just look at the pace of our innovation, when we first started out, or actually in 2011, we started with 18 new significant features that we released in 2011. And then you could see that every year we are releasing more and more features, with the latest being 2,700 features in 2020 alone. So that is how rapidly we innovate. And even internally, it is so hard to keep up with all the new announcement and all the new product features that are happening on a day-to-day basis. I spoke about this. I just want to quickly bring your notice to the fact that we have plans to launch more availability zones in 6 more regions around the world. And I believe the announcements have been made regarding Australia, India, Indonesia, and a few other geographic regions. So what that means is you have more reason to, and we enable your international collaborations given our global footprint. Okay, so now let's talk about how can we help with your research, right? These are some of the main ways we can do that. As I said, we love science, so do not think of AWS as servers, but think of us as how could we help you with your science. You can get to use the computers as and when you need them, and then once you're done with your project, you can scale down or scale up as required. So you don't have to get fully fond of your shiny computer, because with the rate of innovation, that they get outdated very quickly. So you always have access to the latest and greatest out there. In terms of collaboration, you have access to data sets that span institutions, right? So the major part of research is collaboration. So if you're thinking, from my own personal experience as a postdoc, I would have access to some data sets when I was working on a project. And then sometimes we had international postdocs come in, and they would be provided access to specific pieces of the project. And then as they leave, or we have visiting scholars come in. So majority of the researchers, collaboration is important, and that could be done very seamlessly on AWS, right? And you can leverage the work done by other scientists to save time. And very often I run into researchers, particularly postdocs, telling me that they have a specific version of R on their local computer, and then once they get to their HPC or their cluster, it's a different version of R, and now their results are slightly different. And if this is public facing, or if you're sharing your data with others, you would rather have a common platform for reproducing all your scientific analyses, and the cloud or AWS would let you do that. And additionally, having access to the state-of-the-art analytics would not only you can get more value out of your very valuable research data. And obviously, you see there are many cases of malware and academic research espionage. So now more than ever, it's important that you think about how the cloud can provide security to your really valuable research, and you don't have to worry about some of these factors. So let me quickly address the shared responsibility models. Security is our #1 priority, and the AWS cloud has been architected to be one of the most flexible and secure cloud environment, right? So we take care of the security of the cloud. What that means is this is the physical infrastructure, the facilities, the actual compute, and the building blocks that powers Amazon Web Services. And you, as a customer, you take care of the security of the cloud. This means you secure your workloads, your applications, your access on who do you provide access to, and adjust or the security of your sensitive research data, and then adjust as required based on your needs. We have more security standards and compliance certifications than any other cloud offering. And some of our favorite or some of the most favorite compliance that researchers request for, or PCI DSS, HIPAA, FedRAMP, etc. All 117 AWS services that actually store the customer data, they do offer the ability to encrypt the data. Right, so we have, in summary, we have achieved and secured for our customers several important industry recognized certifications like SOC 1, 2, and 3, and the ISO certifications. So you, as a researcher, if you're in an academic medical center or you're enabling research at an AMC that requires a HIPAA compliancy or a PCI compliancy, most of the services, if not all of the services, are compliancy eligible. So please talk to the account team on enabling your research, or if you're looking to get some of these compliance certifications, please talk to us. So, now talking about, what do you see normally in research, right? Typically, researchers come to us, and computation is a big part of everything that you do in research. So I'll kind of like split the next section into compute, and then I'll talk a little bit about data storage, and then let you know or talk to you about, share with you on some of the trends that I see across the board. So to start with compute, it's at the core, right? It's at the core of nearly every researcher's workflows. Whether it is, let us say, a simple computation need where a researcher wants to has outgrown his or her laptop, and then are thinking about using your campus core infrastructure, and then typically, right, I see a lot of times when researchers or postdocs, they have to wait for a few days or sometimes even weeks before they actually get access to their compute core. Or it could be an instance where multiple universities get together and they have a specialized container workflow that they're bringing together for a specific grant they're putting for an NIH proposal, right? And in such cases, whatever your compute need is, we understand that, and we provide you like 3 different options, right? Well, with Amazon Elastic Cloud Compute, it's pretty much like having a virtual server in the cloud. When you're talking about the container management services to run your Dockers on a managed cluster of EC2 instances, we offer the Amazon ECS, which is the container service, EKS, the Kubernetes service, and Fargate. And finally, AWS Lambda, it's a serverless computing service that runs codes triggered by specific events. So we are delivering you choice in how you would like to consume your compute and how to support your existing applications in a way that suits your research needs and that is suitable for you. As I was talking earlier, as your studies are becoming more collaborative and more inter-institutional, your need for computation is getting higher, and there is no one size fits all, right? There are a lot of different server types to choose from, and for example, with each type server type, you can either get a smaller or a larger virtual machine. Some researchers might think about having GPU accelerators. Others might need a high RAM, while others might need heavier I/O operations. And then there are some researchers, like I said, who just have outgrown their laptops and are looking for something a little more powerful. So when you step back and look at all the different options that we provide in terms of servers and the instances and the other factors, we have around 375, more than 375 instance types today. And what still surprises me, even after us having been in AWS, is every year the number of these instances, this number keeps growing. So this 375 plus, it's actually almost 3 times in the last 12 months than what we had in the previous 12 months. So that gives you an idea of how fast we are adding more and more instances. And we can plan to continue to bring new instances to the market, right? We have bare metal instances and to pretty much like support virtually every workload or business need. And then a quick shout out to our Goutam 2 processors that provide about 40% better price per performance. And we have those available as well. So a good example here, let's talk about CPUs first. So the EC2 C6GN instances, they have been announced recently, and they offer about like 40% better performance over the previous version, which is the C5 instances. And they use the same ARM-based AWS Goutam 2 processors. But what has gone better is the networking capacity. Now they offer up to 100 gigs per second networking. And I'm a big fan of F1, and I'm sure some of the folks here are. And also have some exposure to computational fluid dynamics. So when you're thinking about simulations with the cars that go at 200 miles per hour, 200 plus miles per hour, your computational fluid dynamic simulation needs are much higher than what I would do as a grad student. But anyway, Formula One actually uses C5N to run their CFD workloads, to design their race cars or to perform their simulations. And they have actually benchmarked the new Goutam to C6G and the C6GN instances, and they have reported 20% and 40% lower costs compared to the similar workloads on the previous version, which is the C5N instances. And then the other side of the coin is the GPUs, right? So Amazon, the EC2 P4D instances, again, they are provide the best performance for your research applications like machine learning training, and they are powered by the NVIDIA A100 Tensor Core GPUs. They also provide up to 400 gigs per second networking, and they provide up to 60% lower cost to train machine learning models. So we have great options for you, whatever your research workload is, both on the CPU side or the GPU side of things. And as I said, I come from a background in genomics, right? So when I was a genomics researcher and I was doing my whole genome sequencing experiments whole genome sequencing experiments, they take forever to not only the upstream prep where you make your library, you load it on your chip, whatever the platform, an Ion Torrent or an Illumina, you load it on your chip and you get going. There's a lot of time for the upstream genomics side of things. And once you get your sequencing going, you have to actually wait for sometimes more than a day to get your whole genome sequencing out. And you might say, well, some of the genome sequencing runs are much shorter, but that is true only for those tests that have very specific diagnostics enabled. But for, let's say, some orphan diseases or some genomic abnormalities that do not have a specific diagnostic or a test, typically the answer is the researcher would go in and then sequence the whole genome. In such a case, think about your academic medical centers or clinical researchers that are looking at running these whole genome sequences. Time is a very important factor, right? And those are the cases where the cloud could really help you out. And here in this example, the Children's Hospital of Philadelphia actually sequenced 1,000 whole genome sequences, pediatric whole genome sequences, in 2 hours and 25 minutes. That just is super impressive to me as an ex-genomics researcher. In fact, they got a Guinness World Record out of it. But for me, what it tells me is that when time is of concern, when some patients' lives are dependent on a quick turnaround time, these are cases where the cloud or when moving to AWS really is important. So this is one more favorite topic of mine. You know, I as an ex postdoc, I was always thinking about the best bang for my buck of these hard-earned research dollars. Right? You would go put out a proposal, you'd get some feedback, you would go to 1,000 different professors, they give you some feedback, and then after working so hard, you put a proposal out, and then 3-4 months later, you win some amount of research dollars. Now you're thinking about how do I make this spread the most, right? So I always recommend researchers to learn more about the EC2 Spot instances. So Spot instances, what they do is they let you take advantage of unused EC2 capacity in the cloud. They are available about 90% of discount compared to on-demand prices. Because these are tightly integrated with all the AWS services, most like auto scaling, EMR, ECS, CloudFormation, you could pretty much like use Spot instances to run most of your research workloads where time is not a factor, where the spreading your research dollar further, that is more important for you. So these Spot instances are most suitable for you for fault tolerant, flexible, loosely coupled, and stateless workloads. And I have an example here of how Clemson University actually used 1.1 million vCPUs, right? To do a research on actually they ran 500,000 topic modeling experiments using purely Spot instances in one region, in a single AWS region. So that was when I came to know about this use case, I was pretty impressed. It's a total of 1.8 million vCPU hours, but with a total runtime of 2 hours. And given the 90% discount for Spot instances, the total execution cost for 500,000 topic modeling experiments was $32,000, averaging at 1.72 cents per core hour. So researchers and IT folks, enabling researchers out there, definitely look into this. So now we spoke about computation, and the last and obviously the most important part of it is often we have scientists who are telling us that the biggest blocker to enabling the research is, I spoke about this earlier, is the accessibility to their on-campus clusters or an HPC platform. And particularly given a scenario like the pandemic scenario, having the physical access to get to an on-campus cluster is probably not always possible. And as I said, I actually knew some postdocs who would wait for weeks or months to sign up for some of the campus clusters. So high performance computing on AWS removes your these long wait times, and you could be concentrating on your research instead of worrying about signing up for your clusters. And obviously with accessibility to all our services like analytics, AI ML services like SageMaker and databases, obviously HPC on the cloud or HPC on AWS could enable you to get more out of your research, and also your research hours are more valuable. So moving your research to the cloud could have a great value proposition for you. We offer AWS Parallel Cluster and AWS Batch. So Parallel Cluster, it's an open source cluster management tool that enables you to deploy and manage your HPC clusters on AWS. It's a simple text file that you could use to model and provision all your HPC applications. Parallel Cluster itself, it's at no additional charge. It's free. You only pay for the underlying resources that you use, that you provision using Parallel Cluster. And similarly, for your batch operations, AWS Batch enables you to easily run hundreds of thousands of your batch computing jobs on AWS. You don't have to install or manage any batch computing softwares. So you can actually spend all your time focusing on your results. Like Parallel Cluster, Batch is also free, and you only pay for your underlying resources, and they are both compatible. They both work with Fargate, EC2, Spot instances. So if spreading your research dollars is most important for you, and you still want to not waste too much time waiting for those computing resources, using Batch and Parallel Cluster and moving some of your workloads to AWS could be a good option for you. So data storage, this again is a favorite topic of mine. I am 30 something minutes into my talk, so I probably have like 2 more topics, and I'll leave some time towards the end for discussion. Yeah. So these are some of the trends that I've been noticing as I talk to researchers across the board in higher education universities, right? The first thing is, again, like I, as an ex-researcher, for me, spreading those research dollars is super important. And I was always cognizant of that. So some of the free data storage sources that you had, resources that you had, are probably going away due to the changing pricing structures. So I have actually seen announcements at some universities where they're asking the researchers to scale back on their current free storage. And I've seen some announcements where they've asked the researchers to bring the total consumption of data down to 100 terabytes or so, and they're setting policies around your usage of data. So some of your free options are going away. On the security side, as I said, you see a lot. Every day on the news, you hear about some particular research university being held for ransomware, or some kind of a ransomware attack, or some kind of an academic research espionage event that happened. So if you're looking for options for a secure storage of your research data, that's top on the mind for most researchers that I'm talking to. Additionally, you do see that some of the funding organizations, they're pretty much like mandating, you do research with these dollars, then make sure they're available publicly, right? Because this is to enable public consumption. So now the onus is on the researcher to find the most efficient way of sharing this data publicly and making it available for their collaborators or to the general public. Or some platforms are even like mandating that you move to the cloud for a portion of the research. And finally, you see that a lot of the universities, they realize the importance of also enabling the startup ecosystem. So they're encouraging the researchers to actually spin out of the labs and then, take a portion of the research and then, get some equity. Of course, the universities are getting a portion of the equity, but they are encouraging researchers to take the research out and then spin out companies and providing support to do that. So what that means is some of the data that you're generating and getting rid of, researchers don't want to do that anymore, right? You have this latest algorithm and you're looking for data to train these new AI ML algorithms on. So there is no reason why you should be deleting your data. These are some probably like really valuable experiments you must have used, really valuable as a biotech researchers. I know that some of the enzymes I used to used from experiments run into like thousands of dollars. So that little piece of data, it's important that you hang on to it for the next, I don't know, 5-10 years. So these are some of the trends that I'm noticing that researchers are bringing to us and looking for solutions. And AWS could probably help you match your needs against a specific solution or a service, and we could help you do that. Quickly going to the next step. So these are some broad buckets. We have around 6 different storage tiers on the AWS S3, the simple storage service. I'm not going to walk you through all the different tiers, but I try to map it back to, for this talk, I try to map it back to, as a researcher, what are some of the needs that you're thinking about, right? You have current funding. Your funding is current and you need quick access to your data, and your laptops or your on-prem resources are not helpful enough. So for your hard data, right, an Amazon S3 standard frequent tier could be your best bet, where you have like immediate access to it, to your data, and it comes with a lot of security and high redundancy and availability. And then let us say your funding is not active, or you're about to apply for funding. This is a pre-experiment that you did, and you do not know if you're going to get the money, or there is some old data that you are trying to recycle to a new experiment, right? So you cannot set the policies yet, and you're looking for inexpensive storage options for not so hard data. In such a case, based on the scenario, you could probably think about the infrequent access tier or the archive access tier. In fact, there is something also called an one zone infrequent access tier, where the redundancy is lower, but still it is one of the most inexpensive options. So talk to your account manager or the research team about which of these tiers might be a suitable option for you. And then one more use case I ran across is, okay, you have you're not ready to set lifecycle policies around your data, right? Because you're still not aware of your access patterns, you're not aware of your funding scenario. In such a case, we actually have a tier called the intelligent tiering option that moves your data to and fro from different tiers based on your access patterns. So automatically we are delivering cost savings for you. So let us say you have those files that you haven't touched in 90 days. These automatically get moved to your lower storage tier, thereby delivering you a lower cost of storage. And then finally, right, as a researcher, you're getting all this important data. Let us say you're working on a precision medicine initiative. You have your omics data, you have your proteomics, genomics data, you have microscopy imaging data, and you cannot put all these, or you cannot try to build a specific database around this multimodal data, right? Or if you're a research dean, you're thinking about enabling all your campus cores, right? Your flow cytometry core, your microscopy core, your genomic sequencing core, they all have their own different way they store their data. Suddenly, 2 different departments get together, and suddenly they're saying, how can we actually have access to all these different kinds of data and generates and I don't know, go for a moonshot initiative, right? Something big. We want to cure cancer, but we need access to all these different data and different resources. Start thinking about data lakes, right? So Amazon Web Service, the data lakes, we actually offer ways for researchers where you can store your data as is without having to first structure your data. So to support the research or central IT as they build these data lakes, AWS offers the data lake solution. So with this data lake solution, you could truly unlock the true potential of your research data without being tied to rigid data structures. I am almost done. Give me a few more minutes and then I'll open it up for questions. So very briefly, okay, so there are a lot of AWS native solutions, but at the same time, we also have the Amazon Partner Network, AWS Partner Network, where we have 100,000 partners from more than 150 different countries. And so if there are some workloads where you're looking for someone to come in and build a solution for you, right? Whether it is, okay, I have all my data in various buckets. Now I need a partner that would build a metadata, a searchable metadata data storage option. Some of our partners can do that for you. Or whatever your very specific tailored need is, I'm sure there is a partner that could help you. And on the Amazon Marketplace, we have 1,400 plus independent software vendors with more than 4,000 product listings in all these different areas that you could leverage to enable your research, or if you're a research IT person or a dean or something of research, there are some great options for you thinking at a systematic level. And then coming back to, okay, you have all this data, right? And you're thinking about collaboration, but then you or your postdocs or your grad students, you're not cloud savvy. What you actually need is a research environment where you have access to all your different data sources, and you should be able to administrate the access to different collaborators or postdocs as they come in and out. We have options for that. Our service workbench on AWS is a native solution that is available for free. It's and you know, you only pay for the underlying resource utilization. Or we also have partner solutions like Ronin that would enable you to do some of those that would enable some of those needs. And then AI ML, right? Whatever your need is, whatever your research is, everyone, all fields, all domains, genomics or social science research, or any research you could think of, there is an AI ML application in that, right? So why is AWS good for your ML and research needs? First is we provide the broadest and the deepest set of machine learning and AI services, right? So developers with no prior machine learning experience, they could very easily build sophisticated AI-driven applications in areas like computer vision, language, or something through AWS. Second is we accelerate your adoption of machine learning with SageMaker, right? It's a managed service, and you know, all the steps that are included in a typical machine learning workflow, like training, building, tuning, and then deploying a model. SageMaker makes the whole process easy. Or sometimes you are a researcher, but you do not have a data scientist in your team, so you have to go work with that one computational scientist who apparently probably has, like, I don't know, 10 of these different projects, and you're waiting for their time. But look into SageMaker. Probably there is a way to quickly get up to speed on your machine learning needs. And use SageMaker instead. I have a great example here. So Intuit, right? It's a financial company. It develops like what it does. It uses SageMaker to develop a scenario where you can pull like an year's worth of bank transactions, and it uses SageMaker to find deductible business expenses within those transactions. And Intuit actually uses SageMaker for that, and they reduce their development time from like 6 months to less than a week, which is about 90% reduction in time. And obviously, as with everything, you leverage the experience and the length and breadth of services that are available on AWS for your AI ML needs. And lastly, when I think about the AWS ML stack, machine learning stack, I think of it as 3 different layers. For those expert machine learning experts, right? We have the bottom layer, the bottom stack, where we have frameworks and infrastructure for most of your machine learning frameworks like TensorFlow, MXNet, PyTorch, Keras, etc. And in the middle layer are, you know, machine learning services that make it easy for developers and data scientists to, like I said, right, to build your training and to deploy your machine learning needs with like probably a few clicks. And or within that, right, you could use the SageMaker ground truth to quickly train your algorithms. And then at the top are you know, AI services that all developers could use. Probably someone like me me with not much of a great coding experience, probably I could actually use these pre-trained and auto-trained models to add intelligence to any applications that I'm working on, right? For example, Amazon recognition here on the top left corner. It makes it easy to add an image or video analysis to your application, right? Or Amazon Transcribe, it makes it easy for developers to add a speech-to-text capabilities to your applications. And then finally, it's not just TensorFlow, but even with, so with TensorFlow, we deliver about, it's 20% faster on AWS. We did some benchmarking using a neural networks standardized mask on AWS. TensorFlow runs around 20% fast, but also PyTorch and MXNet teams have reported that the algorithms run 22% faster on AWS. Obviously, this is an internal benchmarking, and that's what we report. So I'll end with this example and leave around 10 minutes for discussion. This is a case study by Mike Hogarth at UCSD Health. And well, Dr. Albert Shaw's team at UCSD, they actually used to develop like algorithms for X-ray, CT, and MRI scans. That's the area of their research. And and when the COVID pandemic actually hit, there was an influx of patients that had the ground glass kind of a feature on their X-rays and on their images. That could be a condition associated with pneumonia and with severe COVID-19 cases. So not every patient could be sent to to get a CT, right? That would not only delay, but it would be overload the organization. So UCSD Health actually used Amazon SageMaker to quickly build, train, and deploy a high-quality machine learning algorithm to detect this pneumonia symptom that is associated with COVID-19 cases. This is a great use case demonstrating how you could use the power of AWS SageMaker to get your application running very quickly. So I will end here and open it up for questions. Hopefully, hopefully you have found some value in what I presented.
Yeah, Gautam, that was fantastic. Thank you so much. Let's see, we'll see what kind of questions come in here. And I have one for you that I kind of wrote down while you were speaking. So pardon me, it's a little bit long-winded, so just bear with me here. So this is, my question is not about the glamorous stuff like, AI and ML and so forth, but I find that it really is a ubiquitous problem or challenge, and it concerns data. So I understand that data ingress to the cloud is free. Egress has the 15% waiver. And, to be honest, we advocate a lot in our work for bringing your compute to the cloud so that it completely avoids the question of egress anyway. So that's so far so good. And then we have these tiers of cost. So on AWS, you have object storage S3, you have infrequent access, Glacier, Deep Glacier. And here's the problem, that once a team gets up to, let's say, a terabyte or more of data volume that they want to store for a long, extended period of time, the cost starts to look prohibitive on S3. And then they start looking at, well, maybe we can just buy some disks and stuff. So we find that the basic data storage is really a central challenge in research, right? Where colder rates, like down into Glacier, start to look like, okay, that could work. So what we would wish for is, let's say I put everything into Deep Glacier, and then when I need something, I'm willing to wait a little bit of time for it to emerge back up to the S3 level, but everything else stays down at that, that cost-effective rate. And I'm willing to wait maybe a few hours or a day or something like that for my data to float up to where I can access it rapidly. And I get the sense that you have a service that kind of does this and manages it automatically, but could you give us a sense of, is there a cost with bringing stuff up to S3 from Deep Glacier, or how should we think about this in terms of really making it work for us?
That's a great question, Rob. So I think you have actually laid out the framework very well, or the complexity of the problem. And intelligent tiering was kind of like a product that was designed around addressing exactly that question, right? Where you do not have a specific policy, yet you are still trying to optimize for your cost savings. So yeah, we look at your usage patterns and then move it so that you're always paying the lowest for a given configuration. But I guess my answer is I acknowledge your question. It is very important to researchers, and in terms of providing a estimate of cost to move from a lower tier to a hot tier, we do have these calculators that I can probably provide you, and maybe if there is we can get together and work on a specific scenario, right? For example, I go back to a genomic sequencing center. And there's data coming off of the sequencing machine. It has like variant caller files and some other raw sequencing files. A sequencing center doesn't need to save all the data, right? Because it has a diagnostic, it's looking for just the hotspots. So that variant caller file that does the diagnosis is probably one that they would like to keep it a hot storage, but the raw files, right, they can like throw it in a colder storage. So and then probably like I don't know, for a HIPAA compliancy, they might have to store that data for 5 years or 7 years. So unless someone really asks for this data to be brought back, really it is staying at that deep glacier level, and then at 7 years it could be auto set to expire and the data could get out. But in a specific scenario like that, where we can assume, okay, sequencing center has like so many X number of Illumina MySeqs, it gives so much data, and then let us work through the calculator and see what that could look like, and then optimize it. I know I didn't give a direct answer, but I don't know if my colleague Joel is here to respond.
Hi, Joel from AWS here. Yes, to directly answer your question, the different storage classes of S3, we have two, Glacier and Glacier Deep Archive, which are our cold storage classes. It's built on the same technology, but it's not immediately available. So to answer your question directly, yes, there is a cost to bring it out of Glacier and Glacier Deep Archive. And there are 3 types of retrieval you can use. There's the standard, there's bulk, which is slower but costs less, and there's expedited. So in a disaster recovery, if you needed it right now, you could get it, it costs more. But to Gautam's point, we do have intelligent tiering. So with data in Glacier, you can manually move it to a different storage class. You can set a lifecycle policy that says, okay, after 3 months, move it to this other storage class. But with intelligent tiering, you can just put your data in, and there is a slight extra charge for the analysis, and it will move it to different storage classes for you. An advantage of that, though, is if you need to bring it back out of Glacier Deep Archive, you're not paying that retrieval fee to get it out of there. And also to address your, well, why don't I just buy a bunch of disks? I always like to stress as much as I possibly can without being overbearing that it is very much an apples and oranges thing. We have in S3 built our infrastructure for 11 nines of durability, which is basically if you put 10,000 files into S3, you might lose one every 10 million years. And that redundancy is built in. You don't pay extra for that or anything. You put something in there, it is exceptionally durable, and it's immediately available if you wanted it to. So you, unlike a rack of disks in a SAN, you would have to add more compute power to it if you needed to serve it to a bunch of people. So there's the serving part of it. If a disk drives, yeah, you have an array, you might be able to replace it. S3, you don't have to think about any of that. And it is abstracted so far up from a single disk that it's ridiculous, actually. So bear that in mind. If you needed to, if you were regulated to keep something, like legally you had to keep something, or you have data you really, really want to keep, then S3 has all of this all of this durability built in, as opposed to a bunch of disks where you would have to have different copies at different sites. You would have to have, God forbid, tape or something that is super durable, because a NAS you bought with like 4 disks in it is not anywhere close to the same durability that you would get with S3. Unfortunately, yes, you do have to pay for that. That's where the cost difference comes in.
Okay. Well, this is a huge topic, and we sort of gobbled up all your Q&A time with it. I'm sorry. I'll just throw one more short addendum to this. Marcus Longwell asked, is there a cost to how frequently you move data into Glacier, which I think means, you know, is it cost the same for one tar file write versus a million small file writes? So are those the same?
Same.
Same. Okay, great. So with that, I think we're at time, and I have to make a closing remark or two. So Goutam and Joel and Jeff too, thanks so much for coming in and giving us this presentation. It's been fantastic and a great way to finish out the conference. So I'll turn to address the folks who are still with us here. Just a couple quick final remarks. I wanted to say that please remember that CloudBank is academics working on behalf of academics towards success using cloud for research and education. So that's what we're here for. Look for the CloudBank cloud option in NSF grant solicitation. If you don't see it, encourage your NSF directorate to include this option. CloudBank began in the computer science directorate, but other directorates are adopting it, and we hope to see it adopted more widely. Contact us at help@cloudbank.org with further questions. Please join our community in the broad sense of not just us, but everybody working in this direction to learn faster and share your solutions. And remember that all of CloudBank's education and training resources are open. So you don't need to be an NSF funded person for CloudBank access in order to use our education and training resources. We'll follow up with a post-conference email summary of the resources, including how to get introductory cloud credits to get some hands-on experience. And finally, thanks to the organizers who made RRoCCET happen, and thanks to SDSC for handling all the logistics, and thanks to you for attending, and have a great rest of your day. So long.